I've lived in Arizona all my life. I've lived in Humboldt for the last 14 years. After moving here, my daughter started getting sick, breathing issues. We had her tested. She had arsenic and beryllium in her system. And I started paying attention to our surroundings, what was here. I noticed that only on windy days was she having these breathing problems, so I started investigating more.
Yeah, that's good.
So as I investigated more of what was happening within my own family and the Superfund sites, I met a lot of good people who are also fighting cancers and having breathing issues. A lot of the family members of those people are here tonight with us. My ultimate goal all along, even before I met Brian here, was for somebody to look at the health of the people in town. We have all these agencies looking at the environment, but I wanted somebody to actually look at the people. Tonight will be the 5th time that I've actually sat down and listened to what Brian has had to say, and he has so much information, it can be overloading at times. But tonight is just going to be basic information on the smelter, things that EPA has missed, and the history of where the smelter site sat. What I hope to get tonight is maybe some volunteers that would be willing to help set up a nonprofit organization where we as a community can do some of our own outreach, research on the site, maybe get grants in to do a health study. After talking with Brian, that's about our only chance of getting any funding for a health study is to have an organization. So we're looking for volunteers for that. So that being said, I will hand everything over to Brian and let him share some of his knowledge.
Thank you. Good evening. Just a real quick background on me. I moved up here in 2011, basically as a semi-retirement. Prior to that, I had an environmental company for 14 years, doing all sorts of work in the western United States. Before my own company, I worked for 6 different major corporations. At one point, I was an EPA emergency response manager, where I managed the emergency response contract for the western United States for EPA. Now, saying that, I spent most of my time in Louisiana and in Arkansas cleaning up train wrecks, hardly anything here in the western United States. Anyway, in 2014, the TAG grant was there for the Superfund. Rose Altamar was running it at the time. Her consultant from San Francisco basically left. She found me as a retirement person up here, and I came in and took the position for the TA. We ran, or I worked on that particular thing. Now, the TAG grant, I was the TA, the technical assistant. The whole purpose of the TAG grant, I may have heard it or may not have heard it, was solely for the purpose of taking EPA information and making up other presentations and stuff and communicating it to the group here. We were not supposed to originate any of our own material. We were supposed to just simply take what the EPA was saying and give it back to the group and then take questions and relay it back to the EPA. I broke away from that fairly quickly when I noticed that there were a number of problems with some of the things that were being done. Mainly the history of the site that was done in 2009 by ACS missed quite a few things. And because of what was done from the original contract on the history and the archaeological aspects out here, there are a number of things that were missed. And that's what I wanted to go through here tonight, is present to you the basic history of what has gone on in this immediate area. Mainly, most of it taken from the EPA documentation themselves, the state mine inspector archives, and also the USGS geological survey. By the way, the initials after my name there, PG, stands for Professional Geologist. I have one of the last professional geologist registrations in the state of Arizona before they switched it to a registered geologist. CRS, as my wife says, stands for Can't Remember Shut. But originally it stood for a Certified Remediation Specialist, which last year the state of Arizona went through and got rid of that registration because there was only 16 of us within the entire state. There wasn't enough people in that particular program to continue it on. This presentation, for the most part, was put together in September 2017, about a year after the initial study that was done by the EPA, what was called the remedial investigation, which was issued September 2016. This presentation originally was going to be presented to the City Council and to Yavapai County, but that never occurred because the contract basically came to an end at that time. This comes directly from the Superfund. This is their map of the the city boundary, showing the outline of the Iron King mine and the Humboldt smelter Superfund boundaries. This is the areas that were designated from their study to begin with. By the way, the EPA, when they came in, their sole purpose was to look at heavy metals. That was the sole thing that they were supposed to come in and do. And they missed a number of issues with the entire smelting process. Quick smelter regional history. Our area here became part of the United States in 1848 as the New Mexico Territory, right after the New Mexico War, the Treaty of Hidalgo. 1858, gold was discovered in the Gila River, then the Bradshaws. Some mining was conducted under Apache duress. I like that word, duress. Basically, if you were caught up in the mountains up here, they killed you. 1863, the Arizona Territory was established. 1870, the last of the Apaches were declared to have been removed from the territory. 1871, the first large mines were declared in our area here. 1874, the Agua Fria smelter was established and operated to about 1886. The mines operating at the time were the Agua Frio, Carson, Silver Cabinet, Rebel, Little Jesse, Huron. The ore that was smelted was mainly a lead-silver ore with some copper. So the initial ores and stuff that were processed here by the first smelter were mainly lead. In 1890, the Valverde smelter was established and was operational in 1900. It burned down in 1904. The Valverde smelter was a copper smelter with ores mainly from the Bluebell and other mines in the Poland area brought in by rail. By 1904, the Prescott and Eastern Railroad had been established and was actually servicing all the way down through Poland Junction. In 1907, the Banker Depression shut down the smelter, and under bankruptcy, the Arizona Consolidated Smelting was created. That becomes important in a couple of different aspects. 1912, the smelter was rebuilt to the current configuration and operated through World War I. After 1924, the smelter operated periodically to about 1937. Smelter tailings were reworked by flotation according to the EPA in 1942. I question this. Their reference to what went on here supposedly, I think they have it mixed up because I know that in 1942 that was the mine workings were reworked and not the smelter. Anyway, from 1958 through 1970, the smelter site was used for recycling aluminum and zinc. Oh, I left out one line there, sorry. From 1942 to 1946, the smelter was up and fully operational during World War II, mainly for the production of copper. From 1970 to 2006, the smelter site was used as a sawmill, recycling aluminum and concrete precast. There's a whole bunch of other little things that were done on this site. One thing that's missing in the history, from 1944 all the way through to 1986, Phelps Dodge operated an exploration office on the smelter plateau area. Also, Phelps Dodge was buying ore from the mines around here. They were buying it, bringing it in, then shipping it out by rail to their various smelters. So Phelps Dodge was actually up here, but they never had anything to do with the actual physical operation of the smelter. Just real quick, I threw this in. Iron King mine history. 1902 to 1903 was when the mining claims were located and patented. 1906 to 1910, some mining was done mainly for gold and silver of the oxide ores, using a combination of cyanide and mercury. Less than 5,000 tons were mined during that time. From 1910 to 1922, the site was not operational except for exploration. From 22 to 34, the site was sporadically operated, and a shipment of 10,000 tons of ore was sent to the Humboldt smelter before it closed and was found not to be usable. The ore that was coming out of the Humboldt smelter was mainly a zinc-based ore. And at that time, zinc was not something anybody really wanted. 1934 to 42, the site was operated for mining zinc ores. What was so important was in 1931, galvanization, protection of steel came about, and zinc actually became a commercial item to mine. Anyway, from 34 to 42, about 250,000 tons of ore was mined. During World War II, 1942 to 43, the mine equipment was upgraded, and mining equipment which increased production to 200,000 tons a year. And it continued mining up until 1968. 1964 is when the northeast slope of the tailings pile failed in a debris flow, flowing down into Chaparral Gulch and eventually going all the way down into the Agua Fria River. There's one note saying that there probably 5,000 tons of material actually made it into the Agua Fria River. That's in the mine inspector's file on how much material actually made it all the way down into the river. Up until 68, the mine produced 5.7 million tons of ore, 768,000 ounces of gold, 23 million ounces of silver, 22 million pounds of copper, 278 million pounds of lead, 838 million pounds of zinc. Most people don't understand the Iron King mine was extremely important for the United States during the war years and through the 1960s. 68 to the present, there were numerous explorations of the deposit and to the trend going to the south. Extensive zones of lead, zinc, copper have been found, with gold basically averaging 0.05 of an ounce per ton, with silver about 0.7 ounces per ton. The mine inspector's office has on record from 1971 that the Iron King mine still has in reserve, proven reserve, 5.5 million tons of ore. So it hasn't been mined out. In 1974, Ironite operated the site and is now known as North American Industries. The tailings were being reworked for agricultural projects. So basically, not much has occurred since that period of time with the Iron King mine. But it's important to point out that during the lifetime of the Iron King mine, except for one shipment, they never had any reaction, they did not have any interaction, there we go, with the Humboldt smelter except for one thing going down. Most people thought the Iron King mine supplied all the stuff to this Humboldt smelter. That's not true. Smelter Plateau, that's the stack. That's Main Street. That's Sweet Pea Lane. Here we have Chaparral Gulch, and the blue line here is the Agua Fria. This is a Google shot from 2015. Agua Fria Mill and Smelter. What I'm showing here is the actual patent document from 1878 of the mill site. Up here, the green lines actually show land that was bought and by what's called the General Land Office from the federal government. This is their exact plot. Here you can see the mill building. It shows a water wheel. shows a flume. Back here it calls a ditch. This ditch is still locatable. That's about where the mill and the one smelter would have been located here. Here's a picture from supposedly 1878. This had to be much later, probably in the 1880s. I'll talk about that in a second, mainly because of this building here. As you can see on the patent document that there are 2 beehive furnaces shown, plus 1 furnace with a stack. This is what a beehive furnace would look like. What they did with 1 beehive furnace is they made charcoal. Wood by itself burned too low of a temperature. You turn it into charcoal. Charcoal produces a temperature up to 1700 degrees C. So it will actually burn hot enough so you can do smelting. The second smelter here, the second beehive, was actually used for lead smelting. Lead burns at a much lower temperature than copper. Supposedly, that 1 beehive smelter could produce 10 tons of refined lead per week. So that's basically 5,000 tons, or 500, I had it figured out. It's 500, it's 500 tons a year. Operating for 10 years, that means the maximum that they could have processed here would have been 5,000 tons. The stack, what we're seeing here for this furnace, was for smelting copper. By having a stack, drawing higher temperatures, you can smelt copper. Supposedly it could do 10 to 15 tons a week. So by using that number in comparison to what we're looking at here, or we're looking at probably 15 to 20,000 tons of ore that was processed for copper. So this one smelter here, for its entire 10-year lifetime, might have produced or might have processed 30,000 tons, which is not a whole heck of a lot. And today, that's about 1 week for our modern smelters here in the United States. So where was this thing located? Here's the Agua Fria River coming down. This is Chaparral. Again, here's the plot of where the mill was. You can see the blue line I've drawn here. I actually went out and located the ditch. The ditch is still in place. You come across this low area here, and all of a sudden it drops off 30 feet to the actual Agua Fria River. This entire area has been eroded out to a depth of over 30 feet. So the mill and everything else has been completely wiped out. So, in relationship to the smelter plateau, that's where the Agua Fria mill and smelter was located. Next one to be built was the Valverde smelter. Basically incorporated in 1898. They started building things in 1899, supposedly operational by 1900. This photograph here, the one that's in the EPA report and is done by Charlotte Hall, is highly bleached out. I went to the state archives and was able to obtain this particular photograph. Important features. First one is that's Spud Mountain, Spud Jr. This is a Google shot. There's Spud, Spud Jr. There's the Iron King mine. Here we can see a dump. That's a smelter slag dump. There's a second one here, and there's a smaller one here. There's dump 1, there's dump 2, there's dump 3. Here's foundations. Then we have this funny little trench here. You can see the trench here. And right there you can just barely see in that black, that's a tram. Ore was brought in by rail and was taken by the tram down to the smelter. So this fixes the position of this thing. This thing is sitting on the slope, not up on the smelter plateau. Important things to look at, you can actually see some of the slag being dumped down the hill here. Then we get this weird pipeline coming out and coming down, and you see this black cruddy sludge coming down the slope and through here with another one that way. They were not using charcoal. What they were looking for or using was actually coal. Coal was brought in. They actually took the coal and turned it into coke. Coke was the main material that they were doing. When you do that process, you create a tar-like slag. That tar-like slag is composed of all sorts of secondary waste materials that you need to be aware of, phenols mainly. but it went directly down the slope into the Agua Fria River and through here. This is a vertical shot. Google Earth again, you can see the trench. You can see that's where the rail line was. And again, the slag pile sitting off to the side here. 1900 report territorial to the governor. Val Verde smelter was a custom smelter. It was processing copper and lead ores. Most of the ore came from the Bluebell and the DeSoto mines by rail. Iron King was not in production at the time. Now, the Val Verde smelter burned down in 1904 as reported by the Los Angeles Herald. September 25th is the report date. In it, it states, when a molten matte explosion and attendant fire destroyed the plant with a loss of $175,000. A further report stated the smelter floor was flooded. When the slag hit the floor and set the building on fire. No reports of injuries. Any of you guys out there that have ever been dealing with any kind of welding and you had something hot hit something wet, what the hell does it do? It explodes. And it's a big enough explosion, it's going to kill somebody. Well, in a smelter this particular size, there had to be people there. But they say no reported injuries. No injuries were reported whatsoever. That got me curious. So I went to look at the cemeteries. And sure enough, I found headstones dated September 25th, 26th, 27th in the Catholic Cemetery in Prescott. And the reason that nothing was reported, they were all Mexicans. This is where the Val Verde smelter was located. Down here was the Agua Fria. Here's the Val Verde. I want you to remember these locations. 1906, Arizona smelting started up. Supposedly this is a view to, or it is a view to the west. You can see the smelter's actually more up on the plateau, not down on the slope. And you can see some of the hillsides off the side. But that didn't give me a good enough reference. Again, I went to the state archives and I found this picture. 163 comes, or 163, 169 comes through here. MDI is located up there. That hill and this hill are the two that are sitting right behind us over here. So it gave me a shot looking back. Also in view here is Chaparral Gulch. And we can see the Agua Fria. That Agua Fria is in flood in this particular photograph. I wish we had the exact date on this thing. Here you can see something kind of unusual, but it's actually in some of the early maps. There was a rail line that came down through Chaparral Gulch going down to the Agua Fria. The intent was to build a rail line to the Stoddard mine, Big Hampton and Copper Queen. It was never completed. Anyway, the descriptions say the Arizona smelting state that the smelter was built of the ashes of the former Val Verde smelter. Well, from the previous photographs you saw, it was actually down on a slope, where this one's down up on top, so it wasn't exactly done that way. And again, this smelter processed ores from the Bluebell and from the DeSoto mines. This is where that one sat. So we have the Agua Fria, Val Verde, and here we have the Arizona smelting, so they're very good in close proximity. We're not to the main smelter. Consolidated Arizona smelter. This is a pretty good shot. This view basically is to the east, taken mainly from what's now Main Street and 3rd. The smelter was built after the Arizona smelter closed in 1909. This smelter processed ores from the Bluebell and DeSoto mines, being because it was all owned by the same and controlled people. That's the stack that we see today. Where the rail line comes across through here, that's Sweet Pea Lane. This is a roaster. The mill was sitting over here, and that's the main smelting facility on that side there. So, this is the distribution of 4 smelters. People really didn't know that there were 4 smelters here. If you go back to the old text, everybody thought one was built on top of the other. They're not. They're scattered across that entire area. This is taken directly from the EPA document. This was their entire scope of work on the smelter, on what they were supposed to go after or what they figured to be a problem. Former ore concentration area, former pyrometallurgical dross, slag piles, smelter plateau, which I love that, just plateau, smelter tailings swell, tailings floodplain, lower Chaparral Gulch, Agua Fria tailings. You go through the discussion, everything else, and it goes down to this very last line. No historical operations were known to occur in these portions of the former Humboldt smelter property. Basically, they did almost no work whatsoever on the Agua Fria, the Val Verde, or the Arizona smelting sites. A total of 6 samples were taken out of the 1,000+ samples that were taken across the entire site. By the way, the Val Verde smelter, the Arizona smelter, did coal gasification. They took coal, converted it to coke, and so we had the waste products and stuff coming off of that. The early phase of the Arizona Consolidated Smelter, when they first started up from 1909 to about 1914, it was coal. After 1914, oil became more readily available, and they actually started the conversion over to an oil process. These are the areas that were defined by the EPA. Smelter, tailings, swale, tailings, floodplain, former ore concentration area, here's the stack, former pyrometallurgical area. What I love is they left this completely out of their definition, but this is the slag pile 1, this is slag pile 2, which they had no idea what that was. That's the Val Verde sitting there. Here we have something called the Agua Fria tailings pile, and here's the Agua Fria former mill site, which they didn't locate right. Property boundaries and stuff they're showing here are not correct. But anyway, where the smelter sat down here, the Agua Fria smelter and mill site, to where this tailing pile's up here, the elevation is approximately 60 feet. EPA says that the tailings that they're seeing here, the small pile, came from this smelter. Well, their technology at that time was pack mule, wagon, and water wheel. The tailing pile that we're looking up here fits for copper smelting. The total amount of material up there is around 9,000 tons. So essentially, they were saying that this smelter somehow, since there's no roads built there, took their slag and waste up the hill and dumped it. Not exactly true. Here's the EPA pattern of smelter impacts. Here's the rail line, and they're saying off the rail line, contamination flowed off the sites, off the rail. Here we have the stack. This is the stack plume as indicated by EPA. This is the processing area. This is where there's aluminum dross sitting. That's where they, in the 1960s and 70s, they were shipping aircraft bodies from Tucson up here to reprocess. So it's aircraft aluminum that they were reprocessing up in here, in this dross pile. So the dross pile is actually covering up an extensive amount of material that's actually part of the smelter itself. Here's the debris flow that came down off the Iron King mine, came right on down, came all the way down to the Agua Fria. This is interesting. They call it Humboldt Smelter Tailings Swell. As you can see, it's nice bright yellow. It has the highest acidity out there. EPA completely failed, along with their historical people, to describe what smelters do. Sulfide ores, when they're brought in, cannot be smelted directly. What happens is it goes into a process called a retort, where they actually do a change, or change the ore from a sulfide to an oxide. Oxides you can actually smelt. Sulfides, you get very low conversion rates. And so what we're looking at here is the entire reduction mass, mainly sulfur coming off with all its attended other metal contents and stuff coming out of the soil that was in through here. And then at some point it failed. We don't have an exact date when this tailings pond failed, went down into the creek. Now the only saving grace out here, right in this location, there's a dam, Chaparral Gulch Dam, that was built somewhere around 1914 to 1917 in that time frame. Courvoisier did that when he was the general manager for the rebuild on what's currently out here. That's the only reason this stuff did not get all the way down big time into the Agua Fria River. Then we have the slag pile off the side here, and they don't even show or talk about this other slag pile because they couldn't tie it to anything, an unknown source of slag in that immediate area. Here they're saying from the stack, they have a radial portion of contaminants come off the stack. Here's the main plume. From here, the main plume washed down across this way into the Agua Frio. Here's the problem. Just talk about this first. This is the arsenic distribution and soil map taken directly from the September 2016 map. Every dot out here represents a sampling point, but does not represent all the samples taken at that location. Some of these sample points represent anywhere from 10 to 30 samples taken in that immediate area. When they went out and sampled personal property, they took a minimum of 6 samples, usually closer to 15 samples across the site. All those samples for that particular property were taken and averaged. They did a statistical average to come up with the impact at that particular site. Okay? So they weren't looking at the actual content or the total impact at any individual spot across the property. Arbitrarily, they simply took the entire property and averaged it, or statistical average. And on a lot of properties, one side of it had much higher concentrations than the other. By the time they got through the statistical aberration, a lot of these properties fell out of being contaminated, something requiring cleanup, something I did not like. And that's something, well, we'll get into that in a minute. But let's look at just this area here. This is a detailed Humboldt smelter site itself. There are 58 properties that needed to be some sort of cleanup outside of the smelter and mine area. 50 have been mitigated. 8 refused mitigation.
Oh my goodness.
So there's 8 properties out there that have known contamination that the property owners basically are holding the bag for. For an individual to go out currently, you're looking at about $600 a ton for the disposal cost on impacted soils with arsenic, lead, or any of the other contaminants, and plus the cost of, basically you're looking at $10,000 to $15,000 that people have acquired on this. What kind of mitigation did they do? And this is the biggest problem I actually have with what they did. Anyone that had that done, they went out and took, this is their directive, by the way. The EPA directive was simply to go out and mitigate the initial and immediate threat to the public. Let me say that again. The whole point was to go out and mitigate the immediate threat to the public. So it was to go out, find the surface contamination, and control the surface. They took 1 foot of soil across the entire site. They put down this nice orange material. They put nice clean material on top of it, and they called it done. Now, homeowners got a map, which I've been asking for every single home out here. I wanted to know what the analyses were that were done on the thing, what was the final cleanup, what was left behind. Now, you as a homeowner, and you're going to go in and you have a contractor coming in, you're going to have a new power line put in. You're going to have a new water line put in. What depth is that going to be put in? What is city code? City code for a water line is 18 inches. City code for a power line is 24. So if you're digging in there, you're going to find 6 inches to 1 foot of contaminated material possibly in your site. So that material gets dug up. Does it get disposed of? They never gave you direction on that. So the person doing the work gets exposed, and you're exposed now on your ground, and you no longer have a clean site. That's a major problem that I have with this whole thing. The other thing too, the EPA did not give to the city, or the city did not get onto the contract with EPA that they had for any kind of soil that they dug up to be disposed of at the mine. Because that was never done, the homeowners have this large expense. If that contract would have been maintained to where homeowners running into, or even the city on their properties running into contaminated materials, they could take that stuff and put it up onto the mine site. Now that's not available to them. They'll have to haul it all the way down to Mobile, Arizona. That's where that $600 a ton cost comes from. Plus all the paperwork for everything else that goes with that. Non-smelter and mine impacts that have been found. Smelter mine tailings used for house foundations and roads. That's mainly here. Everything that we're looking at here is pretty much tied to the tailing failure on the Iron King mine. Here it's a mixture between the two. Next one, lead, arsenic, and copper-bearing paints used on houses. That's what this hot spot is. House fire, house burnt down. House was built in the 1930s. I think it was actually 1938. This is actually a common problem throughout most of Arizona. At the end of World War I, there was excess marine paint, battleship paint. Battleship paint has copper as an anti-fouling agent. It has a high lead content to it, also has a high arsenic content to it. It was bought in bulk, and it was used for painting houses. There are hundreds of houses in Arizona that are painted with old excess World War I paint and World War II paint when it became available. In Tucson, it's mainly aircraft paint. Imported arsenic-bearing landscape materials. Again, the information that I requested from the EPA, they came up here, did extensive testing of all the potential backfill material because they wanted a local source to backfill the properties, the private properties out here. They couldn't find one. Every source that they investigated out here had arsenic concentrations higher than their required cleanup standard for the import material. They had to haul it all the way in from Phoenix. In fact, that was about a third of their cost for that work, was the hauling of clean material from Phoenix to come up here. They also found two properties, mainly up in the northern part off of this map. Let's pull it back one. There we go. Right up here. They found landscaping and burn material on that particular property that had been imported in. They would not disclose where the material came from, and the arsenic concentrations were in the percents. Now, the orange circle here shows where the Arizona smelter was and where the Val Verde smelter is. You can see there's only 5 sample points taken in here. Here's where the stack is for the current smelter configuration. The outline I have shown here is the exact pattern you would expect for downwind emissions from a smelter stack. Fits perfectly. Now, something I haven't mentioned before, I worked on the removal of the Morenci smelter, the Clifton smelter, the Ajo smelter, and I got the Douglas smelter delisted and was working for the Phelps Dodge Corporation from 1994 through 96. And this is the exact patterns that we were looking at wherever the wind was consistently, you'd have the material coming down. Now here's the other thing too that's kind of, people don't think about. You have a stack like this, fumes are coming up, they're hot. Well, they're going to go a distance before they start cooling and falling down to the ground.
Sure.
That distance from here to where it first falls down is usually 1 to 2 heights of whatever the stack is. And that's the exact pattern that we're looking at here. And then the maximum area going down is usually 5 to 6 times whatever the stack height is. You can expect that material to fall down, depending upon wind. And the reason that we're seeing the plumes come off in that direction, because that's the standard wind pattern out here. I couldn't believe it when the EPA said, oh no, this is where the plume went out this way, and it really didn't impact anything. I just
Liars.
was upset about that whole thing. The other thing too, the sampling out through here, because of the statistical analysis, the way they did things, they said that these things probably do not need to be remediated. As I pointed out earlier, Val Verde smelter, Arizona smelter, and the first part of the Arizona Consolidated smelter ran on coal. And yet, that was never investigated. EPA did not look for any coal residue. Coal gasification, the phenolic compounds, and all that kind of stuff, that was never investigated. The other thing, too, that was missing out of this, because they never had a floor plan or a building plan of what was actually out here. No one knew where the power station was. I provided evidence to the EPA simply saying, this smelter put a 10-mile power line in to the Bluebell mine. They supplied power. They supplied power to this entire area for about 10 years, up until 1912, when Arizona Power, APS, later on, put the power line in from Fossil Creek, coming all the way down here into Prescott. So we do not know where those particular dumps were. I suspect that they're actually up here. I've had 2 of the property owners tell me that they have found black gooey material up on their properties. I suspect that they're there. To me, that material, that waste material, is far more harmful than the arsenic and lead, because that stuff is tied directly to cancers, mainly liver cancer. Besides the smelter impacts and the mine impacts, people don't understand you're in a mining area. What I've shown you here are the 2 main mineral trends for the area. Here's 69, 169. Smelter area, Mine King. The post office is right up here on Kachina, up in Dewey. Here we have the Galena Iron King trend. The purple zones shown are known economic zones. These are zones where there's still economic potential to be mined. Most of it's patented land. I was actually part of a program in 1981 where we were looking at reopening the Iron King mine all the way up through Galena Gulch and through here. The drilling and stuff that was done at that particular time, we outlined several trillion tons of lead, zinc, and copper. Something on the order of a billion ounces of silver, and a couple million ounces of gold in that trend. It's something that Phelps Dodge was actually very interested in potentially opening up, and Stan West, when they were here in the 1980s, almost pulled it off. If you remember, in 1982, we had the Hunt brothers that killed mining for about 10 years. That's the only thing that killed this thing. East of 69, we have the Copper Mountain trend. Again, the purple zones show known economic zones. The Copper Mountain trend is a copper arsenic trend. Okay? And there's many more small zones all the way up in through this area. This is the Swindler trend in through here. Here's Huron. That's Sadie. That's the Sadie trend. And I've seen all sorts of small ones in through this zone and through here. So again, the Galena Gulch Iron King trend is mainly a lead-zinc mineralization with copper secondary. The form of the ore is galena, a lead sulfide, which is enriched in silver, zinc, sphalerite, pyrite, just an iron sulfide, and arsenopyrite. In the Galena Gulch Iron Trend, in the mineral zones itself, the arsenic in the background runs between 50 to 1,000 ppm. On the other hand, lead can be definitely into the percents. In the Copper Mountain Trend, we're looking at natural arsenic levels in the soils can range into the percents. In other words, more than 10,000 ppm near the mineral zones. So we have a lot of stuff up here. The three highest impacted wells that I know of, that there's been reports to the state of Arizona, have been drilled basically within one of these mineral zones. It's not related to the smelter, not related to the mine. Questions at this time? A lot of blank stares here. I gave you guys too much information. Oh, why did I put the mineral trends in here and the tailings and stuff? The reason I showed you the mineral trends and stuff is there's a lot more out here than just the smelter and the mine. Most of the arsenic contamination within the water supplies out here is naturally occurring. Now, water trends from the north to the south. That's how it flows. The smelter and the mine are at the south end of where most of the wells are. There's only 3 wells that might be potentially impacted directly by the smelter and or the mine. And they're the ones immediately associated with those properties. Now the tailings, again, there's the mill tailings on the mine site itself. Part of the stuff we looked at in 81, those tailings are economic. I mean, you can come in with the modern materials, build a nice mill for probably $100 million now, and process that stuff, and you should be able to make a couple $100 million off the expense of the thing over a 10-year period of time, employing a couple hundred people. And that's what we looked at in 81. Because of the superfund, that's off the table. There's no way to get this delisted. The smelter tailings, those are completely different. The smelter tailings is where they removed materials and it's increased in acidity. So we have a bunch of problems and stuff going there. Now for the naturally occurring materials and for the materials that was taken off the smelter and the mine site and used for homes, there is a problem. Arsenic in the form of arsenopyrite is a stable mineral. You can handle it, you can play with it, it's no big deal. It isn't until you apply an acid to it that it starts to break down. So if you build a house up there, there may be a small little zones of arsenopyrite popping up on your property, and you put a horse pen in. Manure, urine, acidity. Along the same line, there's no sewer system here. You have a septic tank. That's also a source of acidic material to break down material. And everyone has a garden. What do you put on it? Fertilizer. Yeah. Most of the fertilizers you use here are acidic, so you can break down the naturally occurring materials. So there are a lot of different things, but the smelter itself represents mainly from the breakdown of the coal, stuff that is extremely hazardous. And it's linked to several different types of cancer. The cancers that I've been told about up here is brain, liver, prostate, and pancreatic, thank you.
And bladder.
Every single one of those can be related, and there's a huge amount of data on it, to heavy metals. But liver cancer, more important, is more susceptible to individuals with exposure to the residue tar from coal gasification, the phenolic compounds. Then we have the problem with the power plant that was here. They built distribution lines through the entire city out here and also going down to the mine. Well, if you have a power distribution system, what do you put on the lines to translate your power into the homes? Transformers. If you remember, in the 1990s, it was a big deal to find transformers that had PCBs in them. And those are also here. That work has never really been done. No identification's been done. It's stuff that needs to be found. Now, I did find a modern smelter source, the file. The Santa Fe file in Topeka, Kansas. Tremendous amount of records are back there in Topeka, Kansas. They actually have a smelter file. I gave reference to that to the EPA, and the EPA never followed up on it. There's also plans in there. I have all sorts of different sources of information that have just never been gone after. I believe in the Topeka file, or for the Santa Fe file, we could probably pull an actual plan for this site out here. Something we really need to do. Now, the other thing too, thinking about Ashley, because I went over to her house. She has all this lovely brick. The brick is from the smelter. And I have no doubt that there's contaminant, but the smelter that's on her property, there can't be more than 5 to 10 ton. Well, building that smelter in through here, we're probably looking at a couple hundred, if not closer to 1,000 tons. What happened to that brick? Is it in more homes up here? There's all sorts of hidden things that we have, things that need to be looked at. Actually, you had something?
Well, I'm just going to have you explain a little more on why the nonprofit was important for everyone, what we've done with the nonprofit, and what we should accomplish now.
Besides the Superfund site here, there are, I did Port of Los Angeles, 2 Superfund sites there. There's 19th Avenue in Phoenix, the Chevron El Segundo Superfund site. Those particular sites, the only time that work really got done is when the community got together. They formed a community group. They formed a 501c, basically a corporation nonprofit, where they had at least 10, 15 people core, people who could sit down and actually talk consistently about things across the entire area, get their points across. Once that kind of group is put together, and you have a core, real core presence, you can go after and get grants. Here in Arizona, there's a really nice group. It's called the Arizona Community Foundation. They give grants out to 501s, period. They don't will not deal with cities or anything else. In their 30-year history, they put out more than $715 million in grants, including environmental. So you guys need to really get in, form your own 501, get the group going, get the foundations and stuff going, and you can start bringing those grants in. What's the grants for? The thing that is severely missing here, major disconnect totally. And I'm so pissed off at U of A for their failure on this point as well, along with ADEQ and the Department of Health Services in the state of Arizona. They have no indication whatsoever, no proof that there's a problem on this site.
Oh my goodness.
2 points. Number one, the community has not come out. That's the first thing. The second thing is, no one has ever put together a map, a simple map, plotted over time of where people have died of the X, Y's, and Z's. Brain cancer, stomach cancer, prostate cancer, those type of things. And shown the relationship to individual features. Those are cancer hotspots. Those are vital. Those are the things that you have to really go for. Yeah.
How about what we're studying right here now?
Proof comes from an individual giving out a statement, a signed statement, number one, for the current. But more importantly, going back historically, what you do is you show the number of deaths on those particular aspects over time, where you can see it increasing. And you will, 10 to 30 years after a site closes or during whatever life of the material, you can see those deaths increasing over time. Where do you get that information? Death certificates, obituaries. So someone has to go back and do an awful lot of research.
So even like right by the graveyard, we're putting the new houses on the hill and made paths, would that be, pull up a couple foot movement, is that all contaminated too from the building?
This is something that's very touchy all the way around property owners and the city. Does the city have liability? Does the property owner have liability? Arizona real estate law does not recognize environmental, mineral, water, or supportive rights. The only thing they recognize is surface rights, period. And the way they got around that, when the EPA jumped on their case, they came up with a nice little law written into the thing saying the property owner has to disclose. And that's where the basis of several lawsuits are here locally. Properties were sold, the property owner sold it to someone else and they did not disclose. And that's where the lawsuits are going to right now.
How about nowadays, they can go water companies bringing the kids to a new site or something? We would be digging up some of the old stuff?
That's a twofold failure. First one is the EPA did not instruct the city on how to contend with that particular condition. And the city has not taken this information. They've actually became liable when this was published, because this shows where there's definitely areas of contamination. They did not put out an alert through Blue Stake saying, hey, this is a contaminated area. You bring someone in, they have to have some X, Y, and Z training. And there should have been, again, with the EPA getting onto their bandwagon to be able to dispose of material up above or to bring new source material in. It just goes on and on and on.
What kind of
you're not allowed to say it's caused by this.
And
So
my
that takes,
response,
that takes all of you to get together and come to nonprofit and find a way to get a private science person in and do these studies. Because until it's on paper and it's science, it's not real.
I agree that if we don't do the very first part of that by getting the word out, this is cause, this is possible effect. You know, if we don't get out there, yes, it does affect you. And that's almost a house
I
by
believe it, I
house.
believe it, Gary Brockman, I believe it.
But to do that is the first step to do what we need. You're absolutely right, but we have to take the baby steps as opposed to because it doesn't affect you.
Yeah.
Very much.
What are the names of the contaminants that have been found other than just heavy metals? What all?
Question was, what contaminants have been found out here?
Yep.
The whole point of what they did was metals. Because of the non-definition by the EPA on how a smelter works, they didn't even look for the coal gasification stuff or any potential impacts and stuff from that. All they looked at was the main contaminants. Here's the other sore point that got to me. There's mountains of data on acute exposures. That's where your OSHA, PELs, STLs, all those type of things come from. That's for short-term exposures. There's tremendous data on that. It's only been the last 4 or 5 years that data is finally being published on low levels and how they're affecting individuals over time. And it's only very recently. And that, I'm afraid to say, the EPA has absolutely no requirement to look at. The only thing that they're required to look at is their own standards for remediation, and it's for acute remediation, not long-term. Now, the people that go back for long-term, that's the state of Arizona, because they have their own things. In 1994, state of Arizona Department of Health Services published a smelter report on lead contamination of smelter and how it was affecting the population. Yeah.
When we spoke the other day, you mentioned two other contaminants that were not looked at by EPA, cadmium and
Cadmium and thallium.
Where was cadmium found here?
Cadmium was actually a byproduct in World War II of the mine. They actually went after it with a special circuit that was developed in 1944. They did cadmium recovery out here on this mine. They also found on the surface, but they could not tie it to anything, a compound, or actually an element, thallium. Thallium was used in the 1930s and 40s as a rat poison. It's extremely effective on all biological material. But there's 2 hot spots around the buildings up and through there where thallium is found. Problem is, thallium in the Galena Gulch Iron King Trend is found in the ores. We don't know if it was actually brought in or was it a byproduct of the mining that was done. I mean, I could sit here for hours and just go through all the different little things.
What streets were the tar dumped at? You mentioned that.
It's unknown.
Question, what was your question?
Oh, her question was, where has the tar been found? Tar hasn't been found because they didn't look for it. They simply did not look for it. And the reason they didn't look for it, because they had no description that there was a power plant here. They had no description of what the fuel was. All they had is a 1917 description saying that fuel oil was utilized in the smelter. Therefore, all the coal stuff was completely ignored.
The dumping, where did they dump materials? What streets approximately? Okay, approximately what street has the dumping? What? Is that how good? Okay, what streets do y'all know of that there were materials dumped?
I'd have to go back to the map, and that's one thing too the EPA failed at. They did not make the distinction of stuff that was developed in place versus the stuff that was imported or exported. And that goes back to something else. They actually did a major benefit to the city by not doing that. By them not saying their directive, as going from Congress, they were only supposed to clean up anything that was directly due to the activity of the smelter or of the mine. A contractor coming in and taking that material off and using it for a foundation or building a wall or whatever the case may be, that should have been excluded by law. Since they didn't do that assessment, they could go and clean it up. And that's one reason why they did a bunch of things. What I've put up here are some of the issues I had in January 2017. Residential impacted soil removal Mitigation versus remediation. EPA's been handing out things that have been remediated when it's been mitigated. Remediation basically means everything's been cleaned up back to background. Again, mitigation, they simply took the top 1 foot of material off, put clean on, and called it good, leaving the homeowner with a bunch of things. Failure to provide guidance on the remaining impacted materials. Again, like we talked about before, putting trenches on there for new utilities. Think about it. If you got a septic tank and something goes wrong, you're going to bring a contractor in to get that thing taken care of. Direct exposure.
Yeah.
Direct exposure. Failure to provide a mechanism and means to address encountered impact materials. Again, how do you dispose of it? Failure to inform the property owners. Failure to inform the Dewey Humbolt. Failure of the state of Arizona to enforce Arizona regulations. This is just the first part. This is information and data that I requested, which I've had absolutely no response whatsoever. No information and data released on each of the properties mitigated. I wanted to see the site maps, I wanted to see where the sites were taken, and it goes to number 2. No release of field notes on all XRF samples, data, including not limited to GPS map, field map plots, XRF samples, and results. And then a release of information on all properties mitigated. There's been 3 events out here that they've done the mitigation work. Individual homeowners have gotten little pieces of paper. There should be 4 different little pieces. One showing a plot plan. It's supposed to be a summary of the thing. In the first remediation that was done out here, or the first mitigation work, they supplied all that information. The second and third one they did not. What they did is they came up and said, hey, we took 16 samples out here. Statistically, this is what your levels are. This is what we think you're going to. XRF. It's been fully adopted in the last 5 years. XRF stands for X-ray fluorescence. A guy came up literally 10 years ago with a thing that he was a Star Trek fan, so his instrument's field, it looks like a little phaser. That's how he actually designed the thing. It's an X-ray machine. It sits down, you have the material, you put it down, you pull the button, 45 seconds later, it gives you a 32-element analysis. The problem is, a lot of these compounds, like arsenic, you have to have at least 10 parts per million in the sample surface that you're doing it for it to be detectable. Arsenic below it's not detectable. The reason XRF was used because an XRF in a field study, which they did 90% of them through XRF, can be done in minutes instead of sending it off to a lab. And then one person running the XRF unit costs you about $300 a day versus $150 a sample. So it's a cost savings, and it's a good screening tool. It works very effectively, but not for low-level kind of research. And since the EPA is directed to apply only to the acute cleanup standards, that's where the XRF comes in and is really workable. Now, think about this. You go to the dentist, you go to the doctor for an X-ray. What do? You're in a dentist's office, you're going for an X-ray. They put a lead shield over you. And the guy doing the X-ray stands behind a wall with a lead shield. You're going for a chest X-ray, same thing. Guy sits behind 6 inches of lead. Why do they do that? Because X-rays are absorbed by lead. So if you're out here with a gun looking for lead contamination and you're running lead, well, the natural lead that you're working on with the XRF, your readings are actually lower because the lead absorbs the X-ray. So you have to have much higher concentrations of lead for it to be detectable. That's just one example. I can keep going. In the mining industry, XRF samples are great for field analysis and this kind of stuff. except for when you're looking with gold. If you're looking with gold and you have this nice rusty material, if the rusty material is iron in the +3 state, it gives you false reading of gold. So you think you have a gold mine when it's not. So that's an example of when XRFs can really screw you around. But anyway, oops, don't you dare. Come on. Anyway, so that's an XRF, and each type of material. The GPS data, that's where things are located by GPS. Where is it located? Most people don't understand that GPS units, up until recently, there's 3 different datums that can be used for control. The North American datum 27, North American data 83, and the World Geographical System 84. Google Earth works off of 84. Most GPS units has the ability to go in and check your different datums. Well, GPS units by Gorham use NAD 83 as their things. Earth may use GPS 84. The difference is, by using the 2 different datums, the same location by 2 different instruments could be off by 150 feet. All the work that was done in the very first stages by EA, they had 3 GPS units up here and none of them used the same datum. So their locations are all over the place. How to obtain information from the EPA and other sources, any governmental source. 501c through the 5 USC 709 is the way to do it. So what the hell does that mean? Freedom of Information Act. Community Resource LLC 501c with the directive in their operating condition that they are to go out and find and abate environmental conditions, can file a 5 USC 709 Freedom of Information to get the information.
Why can't a private individual do that?
I've requested it and they have denied me. Especially anything dealing with homeowners. They're saying, oh, that's information just to that property. We can't release it to the public in general. The city has the ability to do that, but again, it's going to have to be under a 5 USC 709. A formal request through the Freedom of Information. With the EPA, it gets filed in 2 different locations. The very first one is Washington, D.C. The second one is with Region 9, San Francisco, with the director. The state of Arizona doesn't have this information. The state of Arizona has the Remedial Investigation 2016. And I've made inquiries up there. I don't think anyone has ever read it. It's in their library.
Thank you.
Anything else?
Where can I get a list of the materials that were used? The materials that were used in smelter, you know, other than just the metals, what other chemicals? Where can I get a list of that?
That's another thing that they missed. We do not have an actual written description anywhere. Now, the State Mine Inspector's Office, the Coasve files, which is in the hands of ASU historical files. Coasve, who was the general manager here during the rebuild of everything, became the 3rd state geologist. And all his files, including that one, went into the archives. I've located the archives. There are 42 boxes. Someone's going to have to go through those boxes to find his files relating back to the smelter.
Need some help? Yeah.
This is just scratching the surface barely of the information we have on this site. So that's why I'm trying to get everyone together, where we can continue to have meetings, where we can have, as we do our own investigation, have written questions that we can do next in there. We've got, water treatment stations, we've got all kinds of.
Awesome.